So we're going to move on to trig part 2. We're going to take a bit of a different approach, a different slant, although some of this is going to be repetitive still. I wasn't lying when I said, holy smokes, well over a month ago, you know, after the first 4 lessons, all I'm really going to be doing is showing you new ways to use that X, Y, R cast rule thing. What we're going to be doing today, trig part 2 is divided into 3 main areas. Solving quadratic trig equations with squareds in them. We did a little bit of quadratics, but they were simplified quadratics. They were equations where all you have to do is get the squared by itself, square root, plus or minus. Don't forget the plus or minus. We're going to do ones where you actually have to factor or use the quadratic formula or something like that. Then we're going to branch off into identities. Trig identities is your first real introduction into proofs. Probably the single toughest topic we'll do all year, but I'll be spending probably 7 days on it. Lots of time. It's a weird topic because after the first day, almost every one of you will be lost and nearly in tears, and all I can say to you is, patience. I've done this before. It clicks at different rates for different people all over the room, but it will click. And then the very last thing we're going to look at is applications of trig equations, which looks at similarly with logarithms. We found can we take a word problem, get an equation, and solve it? We'll be doing that with trig. Since this remainder of the unit is calculator based, you will be allowed to use your calculator for parts of this, so it would behoove you if you had one handy for most of the rest of this unit. Those of you that have forgotten yours at home probably want to get in the habit of bringing it and not forgetting it at home, although I appreciate you telling me before the class started rather than sheepishly admitting it sometime during the lesson. It's also my way of saying you might want to get your calculator out. But thank you for picking up the hint. Okay. This first lesson, Ryan, 90% review with a bit of a twist. So it says this: solving first-degree trig equations. A first-degree trig equation is something like this. Don't write this down. That's a first-degree trig equation. That's a second-degree trig equation. You know what that is, Dominique? A third-degree trig equation. Remember doing degree way back when? So, but what we're going to add now, even though we did this last unit, we're going to say, okay, what if we don't restrict the domain to between 0 and 2 pi? So in this lesson, we will be solving first-degree trig equations, yay, where the power of the trig function is 1, something like that. We'll review the algebraic procedure. We're not really going to use a graphical approach because I'm not big on that. I think it's a waste of time. But what we are going to introduce to you, Brett, is this notion of the general solution. This is where I said to a couple of you, I accidentally assigned a couple of general solution questions from the big trig review that I should not have. Or number 2 says, review, use an algebraic procedure to solve this equation here. We should be able to do this as an exact value. How do I know this is an exact value? Just by glancing at it. Tyler, do I have a triangle with a 1 and a 2 in it? Then I can find the reference angle using special triangles. What if instead, Tyler, don't write this down, what if instead we had this? Do I have a triangle with a 1 and a 4 in it? Say no. The only way I could find, I still start out using the cast rule, just like I did over here, but the only way I could find the reference angle here would be to go shift sign of 1 divided by 4, close bracket, enter, and I get a decimal reference angle on my calculator. The way you did it all your trig lives until you learned the 2 special triangles. So from now on, I don't have to ask you a 30, 60, 90 degree, 45 degree, pi by 6, pi by 3, pi by 4, pi by 2 reference angle kind of a question. Now I can branch out again. But this first one, because I know I have a triangle with a 1 and a 2 in it, I'm pretty sure it's an exact value question. We're trying to find the angle, so we would start out by doing a sketch. C, A, S, T. Maria, which trig function did they give me? Sine, positive or negative? Negative. Okay. So what quadrants am I in? Well, A stands for all positive. S stands for sine positive. Oh, I must be in the other 2 because that's where sine is negative. Then, here's where we encounter our first fork in the road. I say, do I have a triangle with a 1 and a 2 in it? Alex, do I? Do I have a triangle with a 1 and a 2 in it? Alex, do I? Yes. Okay. If I didn't, then I'd use shift sign or shift cos or shift 10. Then I'd go to my calculator. But here, we do still also have the... Which triangle, Alex, has a 1 and a 2 in it? Yeah, don't you forget it. In one of those angles, the bottom one or the top one, the sine is 1/2. Which of those angles has a sine of 1/2? The bottom one or the top one? I totally agree with you. How big is this bottom one, which killed a few of you on the test, by the way? How big is this bottom one? Yeah, I saw a lot of you on the test call this one up here pi by 6 a few times. No, got to memorize the triangles. Which means, Alex, that this angle is pi by 6 and this angle is pi by 6. Which means my first angle, Alex, my friend, is that big. How big? I think 7 pi by 6s. Yes, because 6 pi by 6 is halfway across. My second angle, Alex, is how big? I agree with you totally. Now, Alex, that's not the only answers. I could, if I wanted to, keep going. Oops, I got a student late. Hang on here. As I was saying before I was interrupted, there's an infinite number of answers. These are the two answers between 0 and 2 pi. But we did some domain shifting already on the test. There's all sorts of answers. What if I want to list them all, but I don't want to list them all? In other words, what if somehow I want to write, well, what we call the general solution? You can underline or highlight this word here. The generic solution, Kara asks, okay, what if I don't have that between 0 and 2 pi? Now, the other trigger phrase that they'll sometimes use is they'll say, solve over the real numbers. Now, I will, on my test, always say, hey, find the general solution. So that's your trigger phrase for today's little addition. And all we're going to do, Carly, is we're going to say, if you want the general solution, find the first two between 0 and 2 pi, the principal angles, and then show the pattern for finding the rest, which usually means add the period, which is usually 2 pi. Oh, except ugly cousin. Which is the ugly cousin? Tangent. If I'm doing a tangent question, what will I add? Pi. Okay. Next page. Warm-up number 3 says, exploring a general solution using a graphical approach, blah, 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 blah. I just told you the punchline. You know what? They appear every period. So instead, go to page 311. It says, find a general solution using a graphical approach, blah, 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 blah. I'm not big on a graphical approach. We're going to do example 1, but we're going to do it algebraically. Okay? So I'm just going to say solve, cross out where it says 2 different graphical approaches, and write algebraically. Now, I don't think this answer is going to be a special triangle exact value question. Do you know what trigger phrase tells me that? Nearest hundredth suggests this won't work out nicely. Okay? Here's the equation, except I need to get the cosine by itself. Ellen, how would I get the cosine by itself? What will I do with this? Okay, I'm going to solve this. Cos x equals 0.75. And then you'll notice, Mitsu, it doesn't say between 0 and 2 pi. It says, oh, all reals is your domain. Find all of them. Okay. I'm going to find 2 still, Tyler, but then I'll work from there. Hey, what is 0.75 as a fraction? Just curious. Justin, do I have a triangle with a 3 and a 4 in it? That's the other way I knew this was not going to be an exact value question. Even if they hadn't said give answers to the nearest hundredth, I would have said not special triangles. Now, I start out the same way with the cast rule. C-A-S-T. Justin, which trig function did they give me? Positive or negative, according to this question? Really? We've been off both times. Really? Can we spot that? Is that a... Sorry, but we're 0 for 2 now this morning. Ready? Scene 1, Act 1, and take 2. Positive or negative in this? Positive. So where is cosine positive, Justin? Yeah. A and C, 4 and 1. Now, how do I find the reference angle when I don't have a special triangle? Now, it's funny because this is what we did first, and people always forget. To find the reference angle, it's going to be the inverse cos of 0.75 on your calculators, which is why I said you need to get them out. And please make sure you're in radians, especially those that are in Physics 12. And I'll just wait for my calculator to boot up, which seems to be taking astronomically long. Come on. There we go. Mode. I'm in degrees. Nice try. Mr. Dueck. Yes, Asar. How do you know we're supposed to be in radians? Doesn't say between 0 and 2 pi. Okay. This is something that I hate. When it says over the real numbers, it implies radians. I will tell you we're in radians for this whole unit. No degrees. So if did I go radians? I did. Second function cosine of 0.75. Sorry, how many decimal places did they want me to go to here? I'll go to 3 in my reference angle, and then I'll round, because I don't want to round off yet and then round off even more and get error. So I'll go 0.723 as my reference angle. Which means, Joel, that this angle right here is 0.723, and this angle right here is 0.723. Spencer, how big is the first angle? Okay, 0.723. How big is the second angle, sir? Okay, don't forget, we can still use our calculation method. Yeah, it's going to be 2 pi minus 0.723, which I can do in my calculator. Yeah, let's try this again, Mr. Dueck. Come on, pen. Let's work. Minus sign. There we go. 0.723. .56. Okay, now I'll round off. And I'll round off up here as well. 0.72. Now that's the answers between 0 and 2 pi. But they want me to give the answers over the real number system. They want me to give the general solution. How can I list them? You gonna make it, Ryan? You sure now? Because that was a long blink if it was a blink. Okay. I know. Okay. Well, what trig function did they give me, Kara? What's the period of cosine? Okay, here's what we're going to say. For both of these, plus multiples of 2 pi, where n is an integer. You could write that plus 2 pi n next to both of them, but if you're looking for a good time saver, do a great big curly bracket and say, hey, it's on both of those. That's called, Trevor, the general solution. That's really the only addition. We're saying, oh, you want to list them all? Fine. It's going to be over 2 pi. Trevor, as long as there's nothing in front of the x here that would change the period, which is going to be another lesson. Turn the page. Page 312. It says the general solution using an algebraic approach. This is what we're going to do. We're not going to use a graphical approach. It says solve the equation between 0 and 2 pi and then add multiples of the period. Hey, let's go. Use an algebraic procedure to find, there's my trigger phrase, the general solution. This here. 2 cos x minus root 3 equals 0. Carly, can I solve this as is right now? Say no. What do I need to do first before I do anything else? Get something by itself. What? Okay, how would I get the cos x by itself, my child? root 3, and then, okay, so let's go straight to saying this is really cos x equals root 3 over 2. Alex, are you ready? This is your scene 2. Hopefully you'll get it right. Do I have a triangle with a root 3 and a 2 in it, or am I going to have to go to my calculator? Oh, if I got a triangle, then let's use a triangle. Also, did it say anything about give your answer to the nearest hundredth or anything like that? That's also a clue. Okay, Maria, we're going to try this again. You ready? Which trig function? Positive or negative? Hey, there we go, which I think means we're here and here. Alex, which triangle does have a root 3 and a 2 in it? Oh, let's write that out. Which angle has a cosine of root 3 over 2, the bottom one or the top one? Top one right there, adjacent over hypotenuse, is root 3 over 2. Oh, I thought I was giving you a nice slow pitch and you whiffed. All right, finish it off. What angle is the bottom one? I agree. So we're going to get two base or root or primary, oh no, we had a name for that, two principal angles. The first one is pi over 6. The second one is 11 pi over 6. Now that's the answers to between 0 and 2 pi. To find the general solution, add multiples of 2 pi, but add that fact that n has to be an integer for the multiples of 2 pi to work. Again, Ellen, what this is saying is please don't put a decimal there. Don't add 1.62 pi, because that won't work. It's got to be 1 2 pi, 2 pi, 2 2 pi, 3 2 pi, 4 2 pi, or negative 1 2 pi, negative 2 2 pi, negative 3 2 pi, negative 4 2, multiples of 2 pi. That's it. That's today's lesson. Nice little short, shallow end to the pool, hopefully. Okay? Now, I have emphasized using an algebraic approach. For what it's worth, get your calculators out, please. Clear whatever calculators you have there. And let's go back in our book to example 1, the one where I crossed out using a graphical approach. I want to show you how, because you do have your calculators now, Trevor, how you can check your answers. So if they gave me this equation here, I generally prefer to get the cosine by itself. So when it says using two different approaches, I'm only going to show you one. And I would graph left side equals cos x. And then I would graph right side equals 0.75. Before I hit graph, I would change my view window. We're in radians. How about, because I want to see more than one solution now, I'm going to go from 0 to 6 pi. Let's do 3, hopefully, full periods. Hopefully 6 answers. Scale. 1 is a terrible scale for radians. If I don't know, when in doubt, I go pi by 6. 30 degrees is a nice scale. Why not? Y min. Now, we're graphing two graphs. This bottom graph, how high is that bottom graph, Brett? And what about cosine? How low does cosine get? How high? You know what? I'll go, yeah, how about negative 1.5 and 1.5? Kind of nice central. And now I'm going to hit graph. I should get 3 full cosine waves. I do. Remember how to find the first one. Second function, calculate. Intersection. First curve, enter. Second curve, enter. Now I'd like to show you a shortcut. How many answers are there on my screen, Sandali? 6. I want the first one, which is closest to 0. Instead of using your arrow keys, if you just type in 0 as your guess, it'll find the left-hand one pretty nicely. A little quicker than holding the arrow keys down and moving sideways. Is that what we got? Yay! Let's find the next one. Second function, calculate, intersection, first curve, second curve. Right about there. Guess. 5.56, is that what we got? Yep. Now, Brett, can you see this intersection here is actually one period away from that one, and this one goes with that one. These three also go together. So now if I find the third one, second function, calculate, intersection, first curve, second curve, guess. I get 7.006. 7.006 minus the first one, 0.723, gives me 6.28. You know what 6.28 is, the difference between them? It's 2 pi. Isn't pi 3.14? 6.28. So you can also find them graphically. I argue that's way more work than doing it algebraically and not as clean. Oh, but does this work good to check your answers? Yeah. Sure. How do you check an exact value question, Mr. Dueck? Oh, great. Let's do example 2. Y equals, it's still cosine, kind of nice, but instead of 0.75, I'm going to type root 3 over 2. I think the same view window will work just fine, so I'm going to hit graph. There's my 3 cosine functions. Second function, calculate, intersection, first curve, second curve, and since I want the first one, I'm going to let my guess be 0. And it finds the first intersection at 0.5236. See that number? Remember it. Can you remember it for 5 seconds, Kara? So I'm going to go clear, clear, clear. And I'm going to look at my exact value. I'm going to go pi divided by 6. Is that the number that I told you to remember? Oh, there. So that's how I can check an exact value question. I just change it to a decimal in my calculator and then compare it with my... Yeah, that's what I had to. So you can check exact value questions as well. What's your homework? One B and C. Two B and C. Do number 3, but do not use a graphical approach. Hang on, let me just double check. Yeah. Don't use a graphical approach. Just add multiples of the period. Careful tangent, ugly cousin. Number 4, give the general solutions. Five and 6, but again, don't use a graphical approach. So I think 5... I think this is not an exact value. I do have a triangle with a 1 and a 2 in it, but not that has a cotangent of 1 over 2. I'm pretty sure this is not an exact value, and neither is this, because I don't have a triangle with a 3 in it. I got a triangle with a root 3 in it, but not a 3 in it. You okay? Sure? Okay. 7, 8, 9. See if you can figure out 9A. 10. Lots of practice. Do you guys have a number 11? Or is yours like mine, where number 11 is actually question multiple choice? You have number 11? So at number 11, 12, You got 40 minutes. This is good, review, brushing off the cobwebs, getting us back to snuff on solving trig equations.